Hi friends, in this tutorial today we will learn about restricted earth fault protection system, that is REF protection system of transformer, generator and motor. So in this video we will learn about the basic scheme and basic design of that REF protection system and the type, application, protection scheme and calculation, some of the calculations. Okay, so जो इस सेम वीडियो को हिंदी में देखना चाहते हैं वो सेम वीडियो को हिंदी में देखने के लिए लिंक मैंने डिस्क्रिप्शन बॉक्स में दे दिया है, आप वहाँ पर क्लिक करके देख सकते हैं. ठीक है, सो कम टू द पॉइंट. So we will start like this. See, we have on a star winding. Okay, we have on a star winding of the transformer. Okay, earlier what happens that suppose the fault occurred here in this winding. Okay, that means the 85% of the winding towards the line will be covered by your differential protection relay. So what happened that if the fault occurred just near to the neutral point, fault occurred in the winding towards just near to the neutral point, in that cases the angle of that phasor current will not be that much change, so that your differential protection relay can sense and this can operate. So that left 15% of the part of your winding is unprotected. See here in the picture I have shown that this much of percentage of winding which is unprotected. Okay, so in that cases, to protect this part we have used and implemented REF protection relay. Okay, so here is the need of REF protection relay. Okay, so where we use in the transformer, in generator and in the motor. Next, so just consider that REF protection relay restricted earthfall protection relay. The restricted itself describe that there should be a restricted zone, right? So if there is a fault inside the restricted zone, we have already decided, then in that condition only this REF relay will operate. Okay, so just consider that this is the star winding where this neutral is solidly earthed and grounded. There, here is the phase R, Y and V. Okay, so this is the phasor CT and here is the neutral CT. So you have to connect this phasor CT in the parallel. Okay, parallel in the sense the secondary of that CT in the parallel. See here, so just consider this is S1 of this CT, this is S2 of this CT, then this S1 should be connected to the S1 of the Y-phase CT and S2 of the Y-phase CT. Like that, similarly with the S1 of the B phase CT and S2 to the B phase CT, and the same with the neutral CT also, and then this in parallel, this the relay will be connected. Okay, so just consider the same scheme is like this is your star winding. Okay, and then this is grounded, here is the phase CT, here is the neutral CT, and the same thing is shown here, but one external thing is a stabilizing resistor. Here we will talk more about it here in the detail. Okay, so just consider that here there is a two cases. Suppose there is a fault inside the restricted area and there is a fault outside of the restricted area, then whether the relay will operate in the case of outside fault or not, that also we will see here, but here we will see the basic things, basic details how this works. Okay, so just consider there is a fault inside the restricted area. Restricted area in the sense here this CT is working like a boundary. Suppose you would have vowed purchase a land and you are giving a boundary to protect that land, that area, like that here this current transformer will be like a boundary for identifying that the fault is inside the restricted area. Okay, so just consider there is a fault in this winding occurred here at the point of F2, then in that condition this I1 current will be feeding the fault current like this. Okay, then this I1 will be flowing like this in this direction. Then what will happen in the secondary of the current transformer, the direction of the current will be opposite to that of your the flowing primary current. Okay, so this secondary current will be flowing like this. Okay, and this fault current is coming like this and going in the ground and entering into the neutral and trying to make a balanced system. Okay, so this will make a closed path to the neutral, and then this will try to make a balanced path. Then this I1 is flowing to the neutral. In that condition, the secondary of this neutral CT current will be flowing like this. That means the opposite to that of the primary current. Okay, so this polarity, so the direction of this current will be like this. Okay, and as per this arrow, red color arrow, the current will be flowing like this, and this will come here. So this current will be coming like this, and this neutral current will be coming like this, and then both of this current will be added up, and then this will go to the coil of this relay, and this relay will get operate, and then this will give the trip command to the circuit breaker associated connected to the HV side of the transformer and connected to the LV side of the transformer. Okay, so and in such a way this will protect the transformer winding. Okay, so you understood what first case, that if there is a fault inside the restricted area, then in such a condition your relay is operating. But consider the second point, if there is a fault outside of your restricted area, then just consider that I created a fault here outside of this, see, outside of this restricted area here. Then what will happen, see, the direction of this current will be changed. That means this current will be feeding to this point fault F1. Okay, then in that cases what will happen, the direction of this secondary of the CT will change. That means opposite to that of the primary. Then this current will be flowing like this, and this will be flowing like this. Okay, in that condition this fault current will be coming to the ground, and then this will going into the neutral and making a closed path, trying to make a balanced path system. Then in that condition, that the of secondary current of this neutral CT will be flowing like this, and then this will take it this way. Okay, so this phasor CT secondary current will be like this, and this neutral CT will be like this. This two current will cancel each other, and the difference of this two current will be zero, flowing in this coil of the REF relay, and in such a way this relay will not operate. Okay, so you just understood here that if there is a fault inside the restricted area, this relay will operate, and when there is a fault outside of your restricted area, in that condition this relay will not operate. Okay, so you well understood here. The two things are here. One here, a stabilizing resistor, and another is that here this is metro cell, that is also called as voltage dependent resistor, and that is also called as non-linear resistor connected in the parallel, and this stabilizing resistor in connected in the series. What is the purpose of using this and this? I am just discussing you. Okay, so just consider that if there is a fault outside of your restricted area, then what will happen, that fault current is very huge. It's much and more compared to the rating of your CT. In that condition your CT may saturate. So suppose your CT gets saturate, then what will happen, in that condition the secondary current of this CT will become zero. Okay, because this CT will not be able to give the current in the secondary. Okay, because the nature and properties of that secondary will become changed while the saturation. Okay, so this I1 will become zero. So if this I1 becomes zero, then just consider this case, fault is outside and this I1 becomes 0, and but this neutral CT, the current will be flowing through this neutral CT, then in that case this neutral CT secondary is giving the current. Okay, and then this is coming taking this way, then this current is coming to the relay, but from here the current is not coming to this way, then what will happen? The difference of this and this will have some value, and in such a way this relay will get operate. Okay, in case of the CT saturation, right? So to protect that, we don't want that protect we don't want the relay in that condition to operate. So for using that only, we have used a stabilizing resistor. So just consider the case. In the case of outside fault, what will happen? And your CT gate saturates. In that condition, the secondary of the current transformer will have I0, that means the 0 ampere. Then in that condition, this neutral CT current will be coming like this, coming like this, and then this will try to take a this way. Okay, but already we have connected the stabilizing resistor, so this will not go this way, this will go another way and will try to make a closed path. Okay, so this current will be coming like this. Okay, and this will take a this path, and then this will make a closed path. You will ask why this will go to this way? Because in the case of saturation of the CT, the resistance and the inductance of that winding will have a zero value, and in such a way you can say that the impedance of this secondary winding of this CT will be zero. Okay, and that's why this current will be flowing to this CT secondary, and then it will be flowing like this, and it will be continuously making a closed path. Okay, and this will not operate this relay because already we have connected the stabilizing resistor. Because we cannot say that not a less current will go, at least milliamps, a part of this current will be flowing through this, but this will not cause this REF relay to operate. Okay, this will not that much of current. Okay, so you can say that there will be a two part in this way, first one in this way and second in this way, but much more part of this current will be flowing taking this path. Okay, so in case of the CT saturation also you understood. Okay, so you now come to understand that what is the use of this stabilizing resistor. Okay, one more thing is this: what is the use of this metro cell we have connected in the parallel of this CT secondary? Okay, just consider in case of the heavy inside fault. Suppose there is earth fault occurred in the winding which is in the restricted area. Okay, in that condition very huge current is flowing, and in that condition what happens in the CT secondary, there will be a very several kilovolts developed. Okay, that means just consider more than 4 kV, 5 kV, 3 kV, 6 kV voltage will be developed. In that condition your CT secondary wire and relay will not be able to withstand. Okay, so to protect that only we have connected one non-linear resistor in the parallel of your circuit, which will surge that voltage, and this will allow only the permissible voltage as per the setting allowed to the relay coil and in the circuit. Okay, so this is also called as the voltage dependent resistor, and this is also called as non-linear surge arrestor. And practically you would be seeing in the control and relay panel, that is called the metro seal also. Okay, so how it works, I'm just telling you that if the voltage exceeds, in that condition that temperature will increase, the temperature will increase in this material, and the resistance will decrease. If the resistance will decrease, and in such a way this will surge the voltage. Okay, so I'll show you the close view of this, don't worry. So it works like this, and in such a way it protects our secondary circuit. So you just came to understood that this is the purpose of using a stabilizing resistor and then this metro shell. Okay, next, here is the circuit schematic drawing where it is practically shown here. So this is the phasor CT and this is the neutral CT connected here. This is the VDR, voltage dependent resistor, that I explained you, connected in the parallel to this. And then this is RS, that is a stabilizing resistor connected in the series. Okay, and this is your 64 REF relay. 64R is the ANSI code of your REF relay. Like 87 is the differential ANSI code. Okay, so next come to the point. See here, this is your stabilizing resistor. Here it is here it is given the tab, like it is like a rheostat. Okay, you can select the value of the resistance as per your calculation. Okay, and this is the metro shield, which is your BDR, a voltage dependent resistor here that I have shown you this. Okay, so in control and relay panel, this will be mounted like this. Okay, this is the close view. Here it is written metro shell. So this is made of zinc oxide, metal oxide, and how it works I explained you. Okay, see, this is the metro shell. Okay, see here, this nut and bolt. Through using this nut and bolt, it will be connected to the panel using this channel support, and this will be surged through this way. Okay, so here it is written also 1000 ohm and 200 watt. Okay, based upon calculation we have selected and we have used this stabilizing resistor. Okay, so here the same scheme is shown here in case of CT saturation on external fault. That, see, suppose there is a earth fault here and the city gets saturated. In that condition, what will happen? This neutral city current will be flowing here, but since we have used this stabilizing resistor, this will not follow this path, but this will be going like this will be going like this. Since the impedance of this secondary of this city becomes zero, and then this will be making a closed path, and in that condition this relay will not operate in the case of city saturation. Okay, so next, so just consider that what will happen to that delta winding. Suppose if you have a delta winding, then how can you use that REF protection relay? Okay, because you need a neutral CT, right? Because you will have to use the phase CT and the neutral CT. In that condition, you have to use the earthing transformer. Okay, so we will use the neutral of that earthing transformer. There we will connect the neutral CT, and then the same rest of the scheme will be like this. Okay, the same thing like this. Suppose there is a earth fault outside of your restricted area, then that current IF fault current will be coming to this neutral earthing transformer, and this will be making a closed path like this, and this will be going like this. And already we have connected here, just I shown you here the neutral city, and in such a way we will use that scheme. Okay, so there are different things. So we have some calculation also, that I had told you that we will see the calculation that how to find the stabilizing resistor value and then surge arrestor, that we will see here. Okay, in case of inside fault, what will be the peak voltage according to the linear city model? What will be the peak voltage in the city secondary? See here, using this formula you can find it out. So suppose that maximum, what will be the maximum earth fault? That maximum earth fault current here, and then what is your CT secondary rating and CT primary? That means your ratio, like 2000 or 1 ampere, then here it will be 2000 and it will be 1 ampere. And RCT, in the sense the resistance of the secondary of CT, secondary winding of CT, the resistance of the wire connected to the CT secondary up to the relay, and the value of the stabilizing resistor. Okay, okay, so next come to the point. Another thing is there, that what will be the maximum secondary voltage during through fault. So you can find out the peak voltage of the CT secondary in case where the fault occurs inside the restricted area, but when fault occurs outside of your restricted area, then what will be the maximum secondary voltage? Using this formula you can find out. The formula will be the same, but here you have to write the maximum through fault, T for through fault. Through fault in the sense external fault. Okay, and then it will be CT secondary, CT primary, and then RCT. That means the resistance of the CT secondary winding plus the resistance of that wire. Okay, so if you have a non-linear circuit where you have used the resistor and this registers and a lot of things, then that is your non-linear circuit CT. Okay, non-linear CT model, that is called. In that case is what will be the peak voltage of a saturating CT. Your CT gets saturated, and in that case if you want to find out that what will be the uh, peak voltage of your CT secondary, then you can use the P Matthews formula. This is called P Matthews formula. There you can use 2 into root over 2 into knee point voltage. VKP is the knee point voltage, bracket VP just we have found. This is VP, that means the peak voltage during inside fault. Okay, this value you have to put here and minus knee point voltage. Okay, so just see here, using that value you can find out the voltage developed in the CD secondary, and then here we will see that how to find that uh, value of the stabilizing resistor. Then using the simple Ohm's law, the RS, that means the stabilizing resistor is equal to Vs in the sense that the secondary voltage developed, okay, your uh, in case of your inside fault or outside fault, divided by I set in the sense what is your setting current, you say na, what is your setting current. So how much of the value of your setting current you have set, so that's set. So rs is equal to Vs by I set. So this Vs can be found using this formula we have already discussed right here. So we have already discussed here. Okay, see here, see this is the secondary voltage during through fault. Okay, see here, so through fault means, just consider that here we will take one example. Okay, see here, so suppose CT secondary is 2000 bar 1 amps. Okay, and knee point voltage is 100 volt. Okay, and that maximum fault current is 16 kilo amps, that is the 8 times of the normal current, right? Yeah, normal rating is 2000, and maximum current fault current is flowing 16 kilo amps, right? That is the 8 times of normal current rating na. Yeah, and IREF, that is the setting current in the relay I have set 5%. 5% in the sense that 5% will be the secondary, right? The 5% of the 1 ampere. Okay, that means the second 5% of secondary of your CT, that means this will be 50 milliamps. Okay, and the resistance of the CT secondary winding will be 6 ohm. The resistance of the wire connected to the CT secondary is 0.4 ohm, and I maximum fault current in case of inside fault, that is. Okay, so just here consider this is Vs is equal to I maximum through fault, that is the 16,000. See here, 16,000. Okay, this value I have taken, and CT secondary is 1 ampere. Okay, and primary is 2000, and RCT here resistance of the CT secondary is 6 ohm plus 0.4 ohm is the wire resistance. The value is coming 51.2 volt. So 51.2 volt voltage will be induced in the CT secondary when there is a that maximum through fault, which is 16 kilo amps fault current. Okay, so just find out that what will be the stabilizing resistor. Okay, so the Vs divided by I set. So Vs we have found 51.2 volt, and setting current is how much, 50 milliamps, that means 0.05 ampere. So put here we are getting 1024 ohm, just approximate 1000 ohm. If we take a stabilizing resistor of 1000 ohm, then this will protect our relay not to operate in case of CT saturation. So this is how we have found the value of a stabilizing resistor. Okay, and here is this again picture I am showing a zinc oxide. Okay, so if you have seen something, if you have learned a lot of things from this video, then please share this video. Don't forget to subscribe if you like this. Thank you.